As part of one of my first year undergraduate modules, I took on the task of robotically solving the Towers of Hanoi problem. This is what happened. The Towers of Hanoi problem, invented by French mathematician Edouard Lucas in 1883, in its most basic form consists of 3 discs and 3 rods, although it is more common to see 5 or 7 discs. The aim is to move the discs from one rod to another without stacking a larger disc on top of the smaller one. It has enjoyed many creative representations in various forms of media, with video games such as Professor Layton introducing the problem to new audiences. The robot arm solves the 3-disc problem, using blocks coloured red, yellow, and green. Euclidean space was reduced to a 2D representation using a coordinate system. The robot arm itself consists of 5 Dynamix or AX12 stepper motors, manufactured by Robotis. To create movement, the code I wrote sent data packets that update values in each motor's registry to produce an angle of rotation. At first, it was difficult to understand how the hardware was configured and exactly what I needed to do to make the motors move. Eventually, once I figured this out, I took steps to simplify the problem and code a moveset in which as few motors were actioned as possible. However, as we'll see later, this simplification turned out to be a disadvantage. This project was my first practical experience of writing C code that wasn't just an exercise in a textbook. Understanding the software interface I was given was crucial to writing a good solution. The bulk of my time in practical sessions, of which I had 6 hours, was spent on trial and error to get the correct arm positions. This time limit was itself part of the challenge. I had to do most of the design myself at home, so that when I returned to the sessions, I was able to hit the ground running with coding the implementation, and it needed to be a simple enough design that I could realistically code within the time. Occasionally, when I had a bright idea that I needed to experiment with by running the compiler, I would log in remotely to my university's machines. Here is a demonstration of my robot arm solving the problem. You will notice that I am only using 2 of the 4 available stepper motors to move the arm. This was by design. I did not see the need to use more motors when only 2 were necessary at a minimum to solve the problem. The disadvantage though, which I did not anticipate, is that there is a lot of strain on the so-called shoulder motor, and movement is not very fluid, as evidenced by the bounciness. Long term, this could lead to damage of the motor, something I definitely do not intend. Compared with other lab groups, this solution was incredibly primitive. To do well in the assignment, I needed to be self-critical and ask myself whether I matched the design I wrote at home. I certainly succeeded in matching the specification, but I will admit that it was pretty basic to implement. Perhaps this was a consequence of good planning and appropriate modular design. However, I will let you decide as to whether that's true, or whether I was just being lazy. While this time I specified my own design and so made life easier for myself through the simplifications, in the future, when working professionally, it won't matter if it looks a little shaky. It's all about whether it matches what the customer wants.